Hello everyone. In this video, I will briefly demonstrate separation of salt and sand lab. You will be doing this lab at your own. Procedure for this lab is available in Canvas under Home Chemistry Lab folder. You will be reading this procedure prior to conducting the lab and then watch this video and before you perform this lab so that you can learn some lab related techniques. You have to start this lab well in advance of the due date because it may take several days to evaporate the water. In this lab, you will be actually classifying a material which is given in an vial with the unknown number. You will be classifying the material as a pure substance, homogeneous mixture, and heterogeneous mixture. Definitions for pure substance, homogeneous mixture, and heterogeneous mixture you will learn during lecture. So after learning that, you can go ahead and start conducting this lab. So you can read all through this, and there will be some short videos where I will show you how to perform the filtration and how to evaporate and how to dry the sand. So you will see all those steps in this video. Here we have the equipment and supplies. So this section, we have the equipments that you will get from your home lab kit. And then you need some other things like you need a ceramic mug, you need a microwave, you need a Sharpie and a tap water to conduct this lab. So these are supplies that you will get from your home. Read through this procedure. It has a lot of detail and instructions how you are actually going to perform this lab. So make sure you read this procedure. When you scroll through this procedure, you will get this report form, and this is the report form that you will be completing while performing your lab. The first table that we have, it has a bunch of observations and the classification based on the observation. So you will learn the definition of all these three in the lecture, and you will have the observation based on the material that you are testing. And then from that observation, you can just classify those material. The next table that we have is related to the quantitative data and result. The first thing that you will write here is the unknown number from the vial, and then rest of the things that you will take measurements during the course of the lab. One thing to remember in this table is wherever you see this asterisk, it means you have to show calculation on the calculation page, not just you punch in the numbers in calculator and give the answer here. So for this mass of unknown, you will be showing the calculation in this area. Then we have mass of sand, percent sand in the unknown. So all those calculations you are going to show here. After this calculation page, there is a page for questions. Here you will be answering these questions that you have to think based on the lab that you are performing. And at the end, once you have this lab report complete, so starting from this page, you will be attaching these 3 pages to the assignment that is for the separation of salt and sand lab. Okay, so 4 lab techniques that you will learn in this video are weighing by difference. And here is the video for weighing by difference.
Okay, so in this video, I'm going to show you how to perform weighing by difference. Many times in chemistry, the weighing that we perform are weighing by difference. So before I start showing you how to do that, I'll show you how to use this digital scale that we have. This digital scale is the part of your chemistry home lab kit. So there is a power button. I already put the batteries inside. So you will turn the power on, and you have to see that the unit that we need for our chemistry experiments is gram. So you have to make sure that there is a little G here. If you don't see this G, then you press this unit button and scroll through all units until you see G on the screen. Okay, so I have G here. So what you need to make sure that there's G and the reading or the numbers here are 0.00, just to make sure that it is at the 0. And if you don't see this 0.00, and if it is some other number, then you press tear. This tear will reset, and the reading will be 0.00. Before we start our weighing, just to check that the scale is functioning correct, we will take the weight of these quarters. The weight of these quarters are typically from 5.6 to 5.7 gram. So if the weight comes between this 5.6 to 5.7 gram, then it means your scale is functioning correct. So Ima, can you put one quarter on it? Okay, so you can see that the reading here is 5.6, so it looks fine. We will wait until it is 0 again. I'm going to put the second quarter. Okay, our second quarter is 5.66, so which is also within range. Now go ahead and put the third quarter. Okay, and the third quarter is 5.72, so that is the typical range for these quarters. So looks like our scale is working fine. Now, in order to perform weighing by difference, I have this salt and sand mixture that I need to take the weight. If I just simply pour it here on the scale to take the weight, it will be just a big mess here. So that is not the best way of taking the weight. The best way of taking the weight in chemistry is weigh by difference. And to do that, the first thing we do is we take the weight of an empty container. So Ima, can you please put this empty container here? And since we are doing this for our lab, which is called salt and sand lab, separation of salt and sand, and this beaker where we are going to transfer this needs to be labeled as sand. So I have already labeled it as sand, and the weight of this empty beaker is 3.76 gram. I will record this reading in my report form, and after that we will just move this beaker or this container away from the scale and transfer this sand and salt mixture. Okay, and after transferring it, we can put it back on this scale, and the reading now is 8.69. So I have a reading, now I have two readings. One reading is the reading of the empty container, and the second reading is the reading of the empty container with this mixture that I have. So what our target is, we want to find what is the weight of this mixture of salt and sand. So Ima, what do you think what can we do with these two measurements that we have?
Take a difference.
Yes, right. We can take a difference, and if your answer is the same, that we need to take a difference of these two measurements in order to find what is the weight of the salt and sand mixture, then it is correct. So we will take the difference of these two, and that is called weighing by difference in chemistry.
Next technique that you will learn is folding a filter paper, and here is the video for this.
Okay, in this video I will show you how to fold this this round filter paper in a cone shape that can be used to filter a mixture of liquid and solid. So in order to do that, we will fold this filter paper in half. That is step number one. So fold the filter in half like this, and then second is fold it again. So that is your quarter. Okay, so fold it 2 times, and now you can see that you have 4 layers, 1, 2, 3, and 4. To open this folded filter paper, you have to open 1 layer on one side and 3 layers on the other side. Okay, so you can see that when you open it this way, it is closed all the sides inside, right? It is closed all over, and you can just stick this inside this funnel, and when we transfer the mixture of liquid and solid in it, all the liquid will filter through it and all the solid will trap on this filter paper. Okay. One thing that I want you to warn you about is oftentimes or sometime I see that students make a mistake, which is they fold it this way, but when they open two layers on each side, like, and when they open two layers on each side, and if it is like that, right, and they stick it inside the filter paper, there is a hole here, okay, and the solid particles will pass through this hole, and all the solid will not trap on the filter paper. So you have to be really careful when opening this filter paper, that there has to be one layer on one side and three layers on the other side, and look inside this opened filter paper, it has to be closed from inside.
The next technique is filtration, and let's watch the video on how to do the filtration.
Okay, so in this video we are going to show you how to do the filtering. We already have our filter paper all set in this funnel, and I have my Erlenmeyer flask for the filtration to trap the filtrate. So this setup is here. Next we are going to do is we will add 20 ml water in this mixture of salt and sand that we have. So I'm gonna go ahead and put water in the cup. Okay, good job. And then I will swirl it so that I can completely dissolve. Okay, so I will swirl it well so that I can completely dissolve all the salt. Sand will not dissolve, right? Obviously. So I'll just see that looks like all salt is dissolved and there is only sand particles. So once I'm done with that, what I will do, so I started with 20 mils of water. I will make sure that I have one side of the filter paper, one layer of the filter paper on one side and three layers on the other side, and it is closed inside, right? There's no hole. Then I am going to add this in here. Okay. Then we're going to wash this sand 2 times so that we can get all the salt in it, because at the end we are going to take the weight of the salt that we have trapped in this Erlenmeyer flask. We are going to take the mass of the sand that we have. So Ima, can you please put 2 squirts of water inside? Okay, so I'm going to give a good swirl, and I will add it here. And one more time. Okay, so I did washing 2 times. There's a little bit of sand left inside this cup, but which is fine. We already have labeled it as sand. Once the filtration is complete in this filter paper, what I'm going to do is I will carefully transfer this filter paper, and it is almost done. So I will carefully transfer this filter paper and the sand that I have on top, right? I will be transferring it into this beaker, which is already labeled as sand, and I will keep it aside so that all the moisture that I have on this filter paper inside the sand and a little bit in the cup, it all just get dried. Okay, so that is how we perform the filtration. The next thing that I will do is, this is the filtrate, and this filtrate have salt in it. So this is a solution of salt and water. So I will take another cup, and I am labeling this cup with that this is salt, okay? And I'm going to transfer this liquid in this cup. Because we are doing quantitative determination, we will be taking weights at the end. I just want to make sure that all the salt that went inside this Erlenmeyer flask is, we just take all out. Okay, so now this is the beaker that have the salt solution in it.
And the last technique is evaporating without fire. So let's watch the video for that.
Okay, so now we have our salt solution here, and we need to evaporate this salt solution. Normally when we do evaporation in our chemistry lab, we use Bunsen burner to evaporate, but doing a lab at home, we don't have a Bunsen burner. Then let's see how to evaporate this solution. So in order to do that, what I will do is I have this cup, half filled water, and I have heat this water in a microwave. And this water, I heat it like a couple of times so that the water is boiling right now. What I will do is I will put my salt solution in this cup in the boiling water, and I'm gonna leave it there, and the heat from this boiling water will go in the water that we have the salt solution, and it will slowly start evaporating. You may have to do this heating cycle 3 to 4 times. When you see that the water in the cup is getting cooled down, then you remove it and heat this water again, and then put this cup again in here. After 4 to 5 cycles, you will see that all of this water will evaporate, and there will be just salt left inside this cup.
Okay, so let's do the calculation now. So once, so these numbers that I have, these I recorded during the course of the experiment that I was conducting. I recorded the unknown number from the vial. I started taking the mass of the cup that I labeled as sand. So the mass was 3.76. Then I added the unknown salt and sand mixture to it, and I took the weight again, and it is 8.69 gram. You guys can see in the video as well that it was 8.69 gram. And after that, to find the mass of the unknown, remember based on our video in science and chemistry, we take the weights by difference. So you have these two weights, and to find the weight of the unknown, you will be subtracting it. So the subtracting for this will be 8.69 minus 3.76 gram. And wherever you see this asterisk, you actually have to show its calculation in on this calculation page. So the mass of unknown will be 8.69 gram minus 3.76 gram, and it turned out okay. So this will be your number here that you will write 4.93 gram, right? And after that, you will, so once the sand is dry in the cup, like after a day or so, you will be taking the mass again. So that will be the mass of the cup, the filter paper, and the dry sand. So I already took the weight of that, and the weight for that in my experiment is 7.98 gram. To find the mass of sand, so now here you have sand, but this also have the filter paper in it, and it has the mass of cup that we have here. Okay, so you have to write down these numbers, and then you will be subtracting. So the total that we have is 7.98 gram. Then you will be subtracting mass of filter paper and the mass of the cup, the empty cup that we have. Okay, and then you will just do your arithmetic, and you will find the mass of sand. Okay, so I have this mass of sand as 2.91 gram. Next thing you have to do is you have to find the percent sand in unknown. So sand you have here and unknown is this one. So you have to divide this number by this number in order to find percent sand. So for that, we will be doing this calculation here. Here we have 2.91 gram. Make sure you write the units. Then you divide these numbers, and after that you multiply it by 100 to get the percent. Okay. So I have like 59%. 59.0% on my calculator. Okay, now we can start the calculation for mass of salt. So for mass of salt, the very first thing is we need the mass of empty cup labeled as salt. So the empty cup that I started in the beginning and I used, it is 3.87 gram. And after evaporating all the liquid from that salt solution, I just ensure that there isn't any little teeny tiny bit of moisture. It was completely dry when I took the weight, and the weight is 5.84 grams. And again, to find the mass of the salt, it has an asterisk, so you have to show this calculation on the calculation page. So mass of the salt will be mass of cup plus salt minus mass of empty cup. And then you just subtract these numbers. So 5.84 minus 3.87 will be 1.87, sorry, 1.97 grams. So this will be your answer for mass of salt. The next thing you have to find the percent salt in unknown. So for percent salt is in unknown, it will be this number divided by unknown, which is 4.93. So let's do this. So it is going to be mass of salt divided by mass of unknown sample. And when you do this calculation, let's see what we have. 1.97 divided by 4.93 multiply 100. So I actually have 39.9. Okay, so after rounding, I actually have 40.0 percent. So this is going to be my percent of this. So I showed my calculation on the calculation page, and then you have to add the percent of sand in the unknown that you guys can do. In the perfect world, what should this sum be? And so all these questions. So there are many questions that you guys have to read and answer based on your observation and what you are experiencing in this lab. So that is all for this lab. Complete this lab and turn in Canvas. Bye-bye.